Hello friends, welcome to my channel Code for Self, and today we are going to discuss software design principle and one of the core and very important principle, that is solid principle. Okay, so before proceeding and getting more detail, first I will request you to like this video and put your comment. Also subscribe the channel and provide your all your support to me. So now let's proceed to the solid principles and let get it more on it. So first we will understand why solid principle needed. So there are few very uh, important and genuine issues that solid principle solves. So first thing is improve code quality. So with the help of solid principles, our codes are easier to read, understand and maintain, which is very important. Next one is reduce complexity. So solid principles break down complex code into smaller, more manageable pieces. So if someone next are further enhancement, that complexity get reduced. Next one, improve testability. So nowadays, writing unit test cases, automation test cases are essential for any software development. So with help of solid principles, our code are easy to test, reduce the bugs and errors. Next one is increase flexibility. So solid principles make code easier to modify and extend. Next one, reduce dependencies. So solid principles reduce dependencies so that engineers can change one area of software without impacting others, which is very important because if we have to extend new features into our product, into our platform, then other feature should not get impacted during development. So that's how it's work. Next one, improve maintainability. So solid principles increases the maintainability of your code base. We can maintain it. Next one, reduce the impact of prospective changes. So solid principles helps reduce the impact of prospective changes. Again, this is more on if we are enhancing our application, then it reduces the impact. So these are few basic benefits of using solid principles, and that's why we all should implement the solid principles during our software development. Now let's go and check what is the meaning of solid principle. So if we see, solid is word of five. First one is S, that represents single responsibility principle. O, open closed principle. L, Descartes substitution principle. I, interface segregation principle, and D, dependency inversion principle. So that all five principles makes a called a solid principle. Now one by one we will see each principle. So let's go with the first principle, that is known as single responsibility principle. So if you go to single responsibility principle, what this principle said? So this principle states that classes should have only one job or responsibility. So it should have only one reason for change. If you are changing any class, if you are making any class, it should have only one responsibility. It should not be overlapped responsibility or additional responsibility which can be eliminated. So responsibility should be one. Now if I talk about real-time example, and let's go with the managing hotel room booking. Okay, a customer, okay, maybe a hotel wants a system where customers can book rooms. The system should able to do book a room, check its availability, generate a booking confirmation invoice. That's what a customer need if we go to book any room. So if I have to build this kind of system having three features, what if I do as an in general? Okay, so this is the example of single responsibility but violation of single responsibility principle, where is simple design change might merge booking functionalities, availability check and invoice check into one class. And that's what we can see. We have a uh, that is hotel room. This is my class. It is having two properties, hotel room, is booked, it is having method room book, it is responsible for room booking. This is the check availability, that availability is there or not, and then generate invoice. So this all are having in one class, that is hotel room, which is violation of single responsibility principle. From what next we should do as in best practice of following single responsibility principle is, so if I follow single responsibility principle, a more organized approach would separate these responsibilities. So we will have hotel room represents a room's details and its booking status. That's the whole purpose of hotel room. Room booking manager handles the room booking process. That's it. And invoice generator takes care of generating booking invoices. So these my three responsibilities got divided in my three classes, and all are independent and handling the single responsibility. So if I see my class, this is my hotel room, it is having two property and just making sure that is booked, that is true or false based on the set parameter. Okay, this is my room booking manager. Okay, this is also having book room, and the code that is written is all about book room manager. So it's book the room, as well as before that it's check the availability also, room is available or not, and accordingly it take. And once everything is done, my invoice generator go and generate the invite. It's have its own methods. So this way we are segregating all classes responsibility toward the one single responsibility, and that is the whole purpose of single responsibility principle. Now let's move to open closed principle. So open closed principle states that software entities, okay, like classes, models, and functions should be open for extension but closed for modification. Okay, that is very important, because if we are going to class and our intention is to modify that, that is not whole a good um, sign for any software development. We should go change the class for extension to improve it more, not for modification. And if we see the real-time example, okay, so imagine you are developing a system for managing employees' salary. Okay, initially the company only had full-time employees. That is my initial condition. However, the company hires part-time employees and interns on business evolves. Each type of employee have different way of calculating their monthly salaries. So I have one class or maybe system where it is only handling full-time employee, but there is an enhancement that I need to handle the salary of part-time employee as well as interns. So what I will do as in general, so this is the violation of open closed principle. Okay, so open closed principle, how it is violation? Simple approach might evolve hard coding the salary computing logic based on employee type. So simply it will take enum full time, part time, and intern, the employee, that is employee type, hourly rate, and hoursly worked. And this way we can see for each employee type our logic is here only. Okay, so this is for full time, this is part time, and this is for intern, which is wrong. Okay, because if tomorrow, if next type of employee type will come, maybe vendor or maybe someone else, then I have to go and make changes here. That is not correct. So what should be the follow the open closed principle? So if I see the open closed principle, this is the code that's indicate the open closed principle, where I am not modifying my existing code. So how I am achieving it? I have created an interface, that is I employee, okay, double, that is my calculate salary. Again, this all code is just for reference and getting our concept clear to the open closed principle. That's why I am referring here. In our day in day out examples we can do, and much better way correlate our actual piece of software, that is there open closed principle can be applied or not, and in case of yes, then how better way we can apply that. So this is interface I employee, this is my full-time employee, I have an applied interface. why I employee? Because this is the contract, calculate salary. Now my purpose is full-time employee, I need to calculate salary. Part-time employee, I need to calculate salary. Intern, I need to calculate salary, and everyone have their own logic. So this is my class, one class, two class, and three class, all are inherited by I employee, and that is have its own salary. Now I am creating one more class, that is salary calculator. So based on employee, okay, it is just calculate salary. Okay, this is my different method. So if I pass maybe intern, then intern calculate salary will call, otherwise part-time, otherwise full-time, and the same way we can see it here in program.cs. So we can see hourly hours also, it is configurable, maybe 25 hours, interns hourly rate, working hours, so all are, you can see, configurable. Okay, so there is no need to go and change the logic of individual class. That is called open closed. Now let's move to next, that is Lescaw substitution principle, LSP. Okay, so what the purpose of this principle? So this principle states that objects of the superclass should be able to be replaced with the object of subclass without affecting the correctness of the program. Okay, so basically the whole purpose is object of superclass. Okay, so if I say, it's kind of, in our general, we will see the real-time example, but in general also, if some any parents, okay, any parent want their child should be smart enough, should be knowledgeable enough, and should be skilled enough to replace him in sense of wherever maybe parents need to go visit the things, handle the things, transactions, or any day in day out, their parent, their childs also go there, and there is, it's kind of replacement, they should be able to capable that. If they are making that, then definitely they are doing a good parenting. That's why, that's what we can see in sense of now. But we will see the exact real-time example. Let's see real-time example. So vehicle and their engines. Okay, to understand the Lescaw substitution principle, vehicles can have different type of engines. Okay, that is gasoline, electric, and hybrid. Okay, each engine types has a method to start it. However, while gasoline engines use initiation and fuel, okay, electric engines needs, okay, battery check. So this is two different feature of different engines. Now let's go and see. So that's the violation of LSP. How, what violation we are doing? Okay, so let's first see how we can implement without okay, above example, without following Lescaw substitution principle. So this is my demo namespace. This is my vehicle class. Okay, because vehicle class I have created start engine one method, and I am just starting engines need initiation and full. Okay, now I have created a electric class. I have inherited vehicle engine. Now I'm saying that this is the override property of state engine class, and now they can make the changes as per, since electric vehicle, then it is the electric vehicle, and doing that. Okay, this is Lescaw's without using Lescaw's substitution principle. Now if I go and apply the principle something like this, okay, with LSP, let us see how we can implement the above example following the Lescaw substitution principle. So how I'm doing? Okay, again here I'm creating subtract class, that is vehicle class, that is abstract class, means in my base class I'm not creating any body of this method, that is a start engine. Now let's suppose my gasoline vehicle inherited, they will implement by this way, start engine. My electric vehicle implement, they will implement this by their way. Now in program.cs, if I k vehicle engines, okay, I'm creating object is equal to new gasoline engine. So see here, my base class objects are replaceable by my basically derived class, or we can say my superclass objects is replaceable by my subclass objects. Similar here, and they are fulfilling the expectation. Okay, Now if I see each type of vehicle has now its own start engine implementation adhering the Lesko substitution principle. When a client want to start a vehicle engine, they don't need to know the specific engine type. The start engine method will work correctly regardless whether the engine is powered by gasoline or electricity. This means that one type of vehicle can be swapped by with another without affecting the correctness of the program, and following is the Liskov substitution principle. So this is all about Liskov. Now let's move to next principle, and that is called interface segregation principle, ISP. So what this principle said? So this principle is all about classes should not be forced to implement interfaces it does not use. Okay, if does not use, it may be a class should only implement interfaces if it uses. Okay, in other words, interfaces should be designed to be specific to the need of implementation class. Okay, now if I see the real-time example, let's consider a assume, okay, we are developing an animal tracking system with different type of animals having various behavior. Some animals can fly, swim and talk. Okay, so if I go and see the implementation without ISP, then how it is, it's all about I have created an interface that is swim, fly and walk, swim and fly. This is my interface. Now on every class I'm going to implement duck class, cat class, dog class, or any other class, and since it is the interface, then I am forced to implement all the properties even that is relevant to here or not. Even we know the cat cannot be swim or cannot be fly, it is applicable only for walk, but I have to implement because my I animal is having all three. Okay, now let's go to interface segregation and see the implementation. With the help of by segregating the interface, we can make the system more modular. Okay, let's see how we can rewrite the above example following the interface segregation principle. So here what I am doing, I am creating one interface I walker, and there is only walk method, one interface I swimmer swim method, one interface I fly method. And if I say duck, duck can walk, swim and fly. Okay, so I'm implementing art, but cat can only fly, and sorry, cat can only walk, so I have just implemented walk. And at the time of program.cs, we can see if I create a duck class, duck is having all three and cat is having all three. So this is all about interface segregation. Again, let's suppose if you go in any restaurant and you ask for menu, if menu is, even though you are vegetarian, but if menu is having all the vegetarian, non-vegetarian drinks, all the menu options, you may sometime that may not, you doesn't feel more comfortable. But if you are vegetarian, specific to you only vegetarian menu is given, then you are more comfortable, you can choose, you can ask the your order in much better way. So whatever is required to me as a client, that my interface, my contract or related class should be bound with, and that is called all interface segregation. Now let's move to next and last principle of solid principle, that is known as dependency inversion principle, DIP. So that states with high level modules should not depend on low level modules. Instead, they should both depend on abstractions. Okay. So what it means? So dependency inversion principle is basically, we can say it's more on implementing dependency injections. In .NET Core, it is a inbuilt of framework where we created the interfaces, and with the help of interfaces, we try to implement dependency injections and make our classes loosely coupled. Okay, so instead of my actual classes, my interfaces deal with talking with all properties, methods and all. So means there is no such kind of dependency. But now let's go with the real-time example. So imagine you have a system that schedules and performs maintenance tasks for various type of vehicles like car, bike and trucks. Okay, during, depending on vehicle type, maintenance operation can be different. So if my vehicle type is car, bike or truck, definitely my maintenance operation are different. So that's what system I need to build. If I say without DIP, how I will build? So I will go and create my car method, and it is having one method that is perform car maintenance. Everything will be as per car. One bike, and that is okay, that is my maintenance service class. Okay, so maintenance service class, if I pass the car, it is the car performance. If it is bike performance. That's the way it works. Now if I have to implement dependency inversion, then how it is working? So I'm creating one vehicle, that is interface, that is perform maintenance. Now this vehicle will be this I interface will implement to my car class perform maintenance. Okay, and it is having own implementation. Bike, it is having own. Truck, it is having own. Okay, and now system maintain service. Okay, so in maintain service we can see it is having I vehicle passing, as in I'm passing only the interface, and based on the interface it will perform maintenance. Okay, if I see program class, then in here I am just creating car, bike, truck as an object, and with help of passing parameters of car, bike as an object, it is going to perform the that is maintenance, and accordingly it will work. So friends, this is all about solid principle, which we have covered now. Going onwards, this will be the series of software design principles, where I'm going to cover more on ACID principle, CRISP principle, CQRS principle, SAGA principles, and further more on. Okay, so please keep watching, and again, please, if you are new, please subscribe the channel, and please like and put your comment, that keep me motivated to create such type of videos. Yeah, thank you, thanks again.